CV for U1, Chapter 5, Session 3. In this session, we are going to work on Section 5.1, derivatives of exponential functions, y equals e to the power of x. Limit of 1 plus 1 over n to the power of n as n approaches infinity is an irrational number shown by e. E is approximately 2.7183. To see the value of e, we can use a table of values and see when n is getting bigger, it's getting closer to 2.71. As you know, the number of digits after decimal point is infinite, and there is no repetition since e is an irrational number. Log of x base e is called natural log, and it is denoted by line of x. Using a table of values, we can see limit of e to the power of x minus 1 over x as x approaches 0 is 1, and limit of line of x over x minus 1 as x approaches 1 is also 1. The importance of y equals e to the power of x is its derivative. Derivative of a constant times e to the power of x is itself. E to the power of x is an exponential function. The graph is increasing and concave up, and it is between the graph of y equals 2 to the power of x and y equals 2 to the power of 3 to the power of x. The graph of line of x, and to see the derivative of e to the power of x and e to the power of x are equal, we use first principle and we find the derivative of e to the power of x. F prime of x is limit of e to the power of x plus h minus e to the power of x over h as h approaches 0. We factor e to the power of x. Since h is our independent variable, e to the power of x is constant. We use properties of limit and write it as e to the power of x limit of e to the power of h minus 1 over h as h approaches 0. As we mentioned, using a table of values, you can see limit of e to the power of h minus 1 over h as h approaches 0 is 1. Therefore, the limit of e to the power of x plus h minus e to the power of x over h as h approaches 0 is e to the power of x. And that means for function f of x equals e to the power of x, derivative is e to the power of x. We can use chain rule and show derivative of e to the power of g of x is g prime of x times e to the power of gx. This means, for example, derivative of e to the power of 2x is 2e to the power of 2x. Derivative of e to the power of 5x minus 1 is 5e to the power of 5x minus 1. G of x here is 5 to the power of x minus 1. Let's find the derivative of g of x equals e to the power of x2 minus x. the derivative would be 2x minus 1 times e to the power of x2 minus x by using chain rule. Derivative of f of x equals x2 e to the power of x. We use product rule. Derivative of x2 is 2x, derivative of ex is itself. Therefore, derivative of this function is 2x times e to the power of x plus e to the power of x times x2, which is e to the power of x times 2x plus x2. Next example, example 3. Find the slope of the tangent line to the graph of f of x equals 3 e to the power of x2 at x equals negative 1. Derivative of 3 e to the power of x2 is 6x e to the power of x2. 3 times derivative of x2 is 6x times e to the power of x2. Therefore, the slope of the tangent line to the graph of the given function at x equals negative 1 is negative 6 times e. Next example, we want to write the equation of the tangent line to the graph of y equals x to the power of minus 2 e to the power of x at x equals 2. We use product rule and we find the derivative. Minus 2x to the power of minus 3 times ex, derivative of first function times second function itself, plus derivative of ex, which is ex times x to the power of minus 2. Can be simplified as minus 2 plus x e to the power of x at x equals 3. This means the slope of the tangent line to the graph of the given function at x equals 2 is 0, or tangent line is horizontal at this point. The equation of the tangent line would be y equals e to the power of 2 divided by 4. If you use a graphing calculator and sketch the graph of the given function, you'll see at x equals 2, the tangent line is horizontal. Let's summarize what we've done in this section. We showed informally limit of 1 plus 1 over x to the power of x as x approaches infinity is e. We use a table of value and we found e approximately equals 2.7183. We used table of values and we had limit of e to the power of x minus 1 over x as x approaches 0 is 1. Using this limit, we showed the derivative of e to the power of x is itself, and derivative of e to the power of gx is g prime of x times e to the power of gx. The importance of the function e to the power of x, or c times e to the power of x, is the slope of the tangent line at any point on the graph of the function and the y value are equal. To understand the concept in this section better, next session we are working on question number 3, part F, question number 4, part B, question 9, 12, 14, part B, 15, part B, and 16 from section 5.1 of the textbook. Thanks for watching.